Is your Next.js middleware actually protecting your data? Or is it just providing this illusion of security? Welcome to this explainer on the latest Vercel security advisories. Today, we're looking at a pretty critical blind spot in literally one of the most popular web frameworks on the planet. We're talking about CVE 2026-44573. It's a high-severity vulnerability that completely shatters the assumption that your edge middleware is a foolproof security gate. This vulnerability carries a CVSS base score of 7.5. Now, you might be wondering what that actually translates to in the real world. Well, it means network-accessible, unauthenticated access to your application's private data. We're talking about attackers grabbing sensitive JSON payloads directly from your backend without needing a password, a session cookie, or any special privileges at all. And the crazy part? They do it by simply asking for the data in a way your security interceptor just doesn't expect. Stick around because you're going to learn exactly how this happens and, more importantly, how you can stop it. So today, we're unpacking CVE 2026-44573. To give you a one-sentence summary, this is a flaw where Next.js applications using the Pages router, along with internationalization and middleware authorization, can actually be tricked into serving protected server-side data to totally unauthenticated users. This matters right now because, as we know, Next.js powers a massive chunk of the modern web, and relying purely on edge middleware for security, well, it's become a pretty dangerous industry standard. To make this all crystal clear, we've broken this explainer into a 5-part structure. First, the threat itself. Second, how the bypass works. Third, exploiting the flaw. Fourth, actionable security takeaways. And finally, the final verdict. Let's dive right in. Part 1. The threat. CVE 2026-44573. Let's establish the target here. This vulnerability doesn't affect every single Next.js application out there. It requires a specific, yet honestly very common combination of features. You're in the crosshairs if your application uses the legacy Pages router, has internationalization or i18n configured, and relies on middleware or a proxy to authorize access to your data. Now, if you've migrated fully to the newer app router, you're safe from this specific flaw. But for the massive enterprise footprint still sitting on the Pages router, this is a glaring open door. To understand the threat, we really need to define the mechanism. When Next.js loads a page on the client side, you know it doesn't request the full HTML, right? It requests the raw data to populate the page from an internal route that looks like /_next/data. An i18n locale list route is simply a request to this data path that intentionally leaves out the language code. So no EN for English or FR for French. And that missing piece? That is essentially the skeleton key. Moving on to part 2, how the bypass works. So how does leaving out just 2 letters bypass an entire security apparatus? Well, it's all about expectation versus reality between 2 different systems trying to do the exact same job. It's kind of like a VIP bouncer scenario. Think of your Next.js middleware as a super strict bouncer at the front door of a VIP club. The bouncer has a strict rule. They are only checking tickets that have a language code printed on them. If you hand them a blank ticket, they don't even recognize it as a ticket, so they just ignore you and let you walk right on past. But once you're inside, the backend manager is incredibly permissive. They see you have a blank ticket, and instead of kicking you out, they say, "Oh, hey, you forgot your language? No worries, let me just stamp English on that for you. Go right ahead into the VIP room." The gateway is strict, but the backend is incredibly permissive. Looking at the original design intent, developers really wanted a centralized routing policy. One middleware file to just secure everything. They knew client-side transitions fetch data via that /_next/data path. But here's the fatal assumption. They assumed the regex capture group, specifically the Next internal locale group, would universally cover all valid data routes. The engineering team simply didn't foresee a scenario where a request could fail to match the middleware regex entirely, totally skip the security check, but still be perfectly understood and rendered by the highly resilient back-end routing engine. Which brings us to part 3, exploiting the logical flaw. Okay, we know the flaw exists in the framework's logic, but how does a hacker actually pull this off without any authentication? Let's look at the attack vector. You might be surprised by how shockingly low the attack complexity actually is. It's practically child's play. Here's the exact step-by-step flow. First, the attacker visits any public, unauthenticated page on your site. They view the page source and look for the globally rendered next_JSON script element just to extract your unique build ID. Second, they craft a URL to a protected page, but they intentionally strip out the locale prefix. Third, they send a direct GET request to this modified data URL. Because there's no locale, the regex fails and the middleware is completely bypassed. Finally, the backend router steps in, automatically assigns the default locale, and happily serves up the protected JSON data. I really want to emphasize the critical impact here, guys. The backend executes get server-side props. This function goes straight to your database, fetches the data for the page, and serializes it. Because Next.js server-side rendered JSON payloads are identical to the complete state object passed to the front end, they expose absolutely everything. We are talking about personally identifiable information, session states, configuration details, and backend API keys. All of it handed directly to an unauthenticated attacker on a silver platter. All right, on to part 4, actionable security takeaways. Okay, enough doom and gloom for a minute. Let's talk practical takeaways and look at some immediate remediation strategies. Because if you're running a vulnerable version, you absolutely need to act today. Here's the affected software scope. Next.js versions from 12.2.0 up to 15.5.15 and 16.0.0 up to 16.2.4 are vulnerable. The official patches are available in versions 15.5.16 and 16.2.5. Basically, Vercel updated the compilation logic so the generated regular expression treats localist data routes exactly the same as standard routes. And importantly, if you're running an older end-of-life version, say anything under 12.3.14, commercial backport patches are available through services like HeroDev's never-ending support. So the absolutely crucial point is this. If you're a developer, your immediate action is to upgrade the framework. But beyond just applying the patch, you need a fundamental mindset shift. Do not rely solely on middleware. You must implement redundant authorization directly inside your data fetching layers. Add your token checks and your session validations right inside get server-side props. You want to establish defense-in-depth security so that even if the edge gateway fails for whatever reason, the data layer itself will flat out refuse to execute. Now, if you're a security engineer monitoring these systems, you need to be inspecting your web server and CDN logs specifically for those localist data requests, especially those returning 200 HTTP status codes to unauthenticated clients. Compare the request volumes between localized and localist paths so you can spot any anomalies. And just a quick word of caution regarding web application firewalls, be very, very careful with global WAF rules here. Blocking all localist requests at the edge might inadvertently break legitimate application behaviors, so custom, highly tailored rules are definitely the way to go. Finally, part 5, the final verdict. Let's bring this all together. This explainer isn't just about a single missed regular expression match, right? It's really about a fundamental lesson in modern web architecture. As the security analysis correctly states, relying solely on middleware-based edge security represents an anti-pattern. The key takeaway here is that security validations must be placed redundantly and as close to the target data as humanly possible. When your edge gateway and your backend router don't perfectly agree on how to parse a URL, you better believe attackers are going to exploit that gap in between. Which leaves us with a pretty provocative final thought. Does your application's edge gateway truly align with its backend routing logic? It's definitely a question worth asking your engineering team today. Thank you so much for joining me for this explainer. If you found this breakdown valuable, please hit subscribe, comment below with your questions on defense-in-depth architecture, and definitely check out the description for links to the official advisories, patches, and security resources we mentioned today. Stay secure out there, and I'll see you in the next explainer.